Example 1, we are going to apply Cavalieri's principle to pyramids and cones. So we saw this in our last lesson. So now let's talk about pyramids and cones versus the prisms and cylinders. So the question we're being asked, how are the volumes of pyramids and cones with the same base area and height related? So let's start by taking a look at a couple different cones. Here we have a cone, and we are told that it has the same base area and the same height. So how are these two cones related? This cone right here, if you notice that from the top of the cone, the height is straight down. Remember, the height will be perpendicular to the base, and it is hitting at the center of that circular base. So this would be considered a right cone. This cone over here is kind of slanted. This is our oblique cone, where the height of the cone is, from the top of the cone, the vertex, straight down perpendicular to the base, but this height is not hitting the center of our circular base. So you can see it's oblique. It's a little bit tilted. So what we notice is that the heights of these two stacks of discs, whatever we want to call them, the heights of the stacks are the same. And then at each level, the area is the same. So here we have the circular disc. Here's that same circular disc. Those would have the same area. This next circular disc is this same one right here, just, pushed over a little bit. So the area at each level is the same. And you can consider this kind of the area of each cross section. So the area at each level is the same. So what that tells us is that the total volume of each stack will be the same. So why don't we take a look at a pyramid versus a cone. So here's a cone, here's a pyramid. We can see that they do have the same height. So the heights are the same. And then what we're taking a look at are cross sections. So this cross section is circular, this cross section is square or rectangular, I guess we're not sure, but they're telling us that they're equal. So if the areas are equal of these cross sections at every level, then they will have the same volume. So if you have the same height and the same area at every level, you will have the same volume. So we can summarize this by saying pyramids and cones will have equal volume if the height is the same. And the area at each level is the same. So that's going to take us to volumes of pyramids and cones. So the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So our volume formula, volume equals 1/3 the area of the base. So we use a capital B times H, the height of the pyramid. All right, so remember capital B stands for area of the base. We want to remember capital B has significance in what it means. All right, so how about a cone? The volume of a cone is 1/3 the product of the area of the base and the height of the cone. So what we notice is this volume sentence is the same as this. So cones and pyramids have the same volume formula. What they have in common is they both have one base. So a pyramid has one base, a cone has one base, and they have one, vertex that we come to at the top. Here's our one vertex that we come to at the top. So the volume formula for a cone is 1/3 the area of the base times the height. Now we can get a little bit more specific with the volume of a cone is the base is always going to be a circle. So similar to our cylinders, because we know the area of the base, or the base will always be a circle, we'll always find the area the same way. So we can just get a little more specific. The volume of a cone is 1/3. The area of the base will be pi r squared and then times the height of the cone.